All right, so this is the second part of the cryptography, and it's the modern cryptography. فإحنا شفنا while looking at classical crypto that we have fundamentally two problems. Key size. If we have a small key, then the algorithm can be broken, and we know we can increase the key size. The big other problem that we have is frequency analysis. So frequency analysis, we already saw what Vigenère tried to do by using different keys in different locations, right? And this is also one-time pad. Vigenère Cipher tried to do it. However, the way that Vigenère Cipher tried to do this was able to be broken because the Kasiski algorithm and doing some divided stuff. But the modern crypto used this and created what is called the stream ciphers, which is using different keys at different locations. The second one of doing frequency analysis is what is called, instead of encrypting, so the reason that frequency analysis exists, because I know that E is the most common thing. I know that A is the most common thing. I know that T is the most common thing. But is those three together the most common thing in this order? Or is like, or in this order? Or in this order? No. And if I put another letter, and another letter, and another letter, then I start by increasing the size of the transformation, I start to reduce the probability of frequency analysis. So having a sequence of, one letter is 8 bits, but having a sequence of like 64 different bits, which is 8 letters together, it no longer have the frequency analysis problems that I've seen before. And this is what is called block ciphers. So we will talk a little bit about stream ciphers and block ciphers in the following slides. So I will say stream ciphers. So we talked stream cipher, we loved what one-time pad is doing, but we said this is not practical, right? Because the 3 problems. It needs to be truly random, you cannot repeat it, and it needs to be as long as the plain text. So what Stream Cipher did, and they said, you know what? Let me change those problems. And instead of having true random, we will have what is called pseudo-random. And a pseudo-random number generator takes a seed of a small size n and generates a really long sequence of bits of a size n, and n can be infinitely large. So S can be مثلا 128 bits, and n can be like, I want millions and millions and millions and millions of bits. This is how a pseudo random number generator works. The PRNG, pseudo random number generator. So I replace the need of random to a pseudo-random, right? And then my secret key of, instead of being that long list, it becomes this like seed. That becomes my secret key. And the way that I encrypt M, I take every bit of M and encrypt it using the output of these pseudo-random number generators, right? So I'll take an example here. إحنا قبل, what we had is we did not have this. We immediately have the random sequence of bits. بس حين جالسين نقول no. Like now, we're going to feed a short هنا مثلا 128 to this. And this will create what is called the key stream, an n number of bits long, right? And I'll take bit number 1, XOR with bit number 2, XOR with the plain text number 1, K1, K2 with K2, K3 with K3, all the way to N. So I can have N as long as the plain text that I have. The question is, طيب, if I wanted to decrypt أول شيء before this, so here, so if I give the same key to this pseudo random number generator, key 1, I give it first time اليوم, today, right? And then tomorrow, right, I give it key 1 again. Do I have the same key stream in both times, or is the key stream is going to be different? أحمد تفضل.
بيكون نفسه.
بيكون نفسه بالضبط. لأنه ليش؟ لأنه that's the secret. أنا اليوم موجود عندي الكي. This is my secret. أعطيه أحمد وأقول أحمد okay. Now this is the secret that we share one time. أنا وياك نتفق عليه. And then I send you this. Then I'll get the long key stream generator. And then you can encrypt. I encrypt and you receive it and you can decrypt. So if you give the algorithm the same key, seed, it will always give you the same key stream, right? So, and this is exactly why, yes, we need this to be able to decrypt. Like, what makes a good pseudo random number generator? A good pseudo random number generator has two properties. The property الأولى is what is called the next bit test. بمعنى يقول لك when you have like 0 1 1 0 0 0 1 1 1 1 1 1 1 0 1 0 1 and then bit هنا. So المفروض if you see all of those, this can be obviously either 0 or 1. A good pseudo random number generator, if you see this, you don't have more than 50% chance. It's a 50% chance that it's a 0 or a 1. Knowing all this information, the next bit test means you will not be able to have any ability to guess the next bit in this particular pseudo random number generator. And the other property is called stays compromise extension, which means if you see all of those, right, and you want to guess the bit that actually came before here, when you see all of the sequence of bit, again, you only have a 50% chance of success, which is no better than random. So a good pseudo random number generator, إذا أنت شفت البيتس هذه, you cannot guess what's next, or you cannot successfully know what's next, and you cannot successfully know what's behind, which means seeing a sequence of bit, you cannot, it satisfies the next bit test, and it satisfies the state compromise extension. طبعا pseudo random number generators are very useful here, and they're very useful to change what we call temporary keys that we're going to be seeing later in class. So what are the properties of those stream ciphers? الأولى, stream ciphers are super fast. لأنه إحنا we know the XOR function is the fastest function that you can execute in a CPU. The other property is that if you use the same stream cipher, if you use the same key stream, right? If you use the same key stream twice, then you can break it. That's interesting. So let's talk a little bit why. So let's say احنا like we encrypted 2 bits, C1 equals P1 XOR K1, and then we have C2, right, equals P2 XOR K1, صح؟ لأنه it's the same bit, right? So let's say, let's call this C1 par P1 par. لأنه هذا البلين تكست الأول P1، plain text الثاني P1 par. هذا مثلا أحمد، هذا علي. اللتر الأولى A، اللتر الثانية عين. I want to send this twice. So all of them are encrypted using K1. And we know in XOR, I can simply put the K in one side. فهذه تطلع لي. So if I go here, it will become K1 equals C1 XOR P1. And K1 equals C1 par XOR P1 par. صح؟ I just moved things this way. طيب أنا أعرف إن الطرفين هذه زي بعض K1 and K1. So شو بيطلع عندي؟ بيطلع عندي C1 XOR P1 equals C1 par XOR P1 par. So I actually see the cipher text. I know the cipher text, right? So very simply, these two things are knowns. لأنه هذا encrypted text. So if I want to move P هنا, it will become and C1 par هنا, so it will become C1 XOR C1 par equals P1 XOR P1 par. So I know those two things. This can be either a 0 or a 1, لأنه I know the result. I don't know those two. But statistically, if I have enough data, I will be able to get better than a 50% chance of guess, statistically. And this defeats the security. بمعنى أن الأتاكر has a chance to guess this better than 50%. Maybe not 100%, but definitely better than a 50% chance. So the way that we solve this in, okay, let me not, okay, go through this in details. We use something called initialization vector that we will get to when we talk about RC4 and as an example. But remember اليوم, if you use the same stream twice, the same key stream twice, then the algorithm can be broken. Highly malleable, what does that mean? Means if I flip, let's say this bit was 1, and when it arrived, and then let's say K1 is actually 0, so which means P1 is 1. So let's say it goes through the wires, and because of electric magnet, this bit get flipped and it became 0. So when I XOR 0 XOR 0 يطلع عندي 0. So one bit flipped and immediately affected the plain text. Can I know that this bit is flipped? I cannot know that this bit is flipped لأنه كل bit لحالها فبتوصل كلهم مع بعض and I have no idea that this bit is being flipped. And this affects, it doesn't affect the secrecy. It doesn't affect the confidentiality. If the bit is flipped, people would not know what is the original flip is, but it will affect the integrity. لأنه I could decrypt and I get a 0 instead, and I don't know, and then if I use it, this might break my system. But the attacker would not know that I got a 0 instead of the 1 because they have no idea what the results are. So طيب ليش OPT الآن عفوا stream cipher is better than a one-time path? 3 things. الأولى, keys are shorter. We're using S keys that are 128 bits. ما يحتاج it as long as the plain text. Randomness غيرناها from a true random إلى something generated by a pseudo random number generator. And by the way, I could reuse the key احنا قلنا you can't reuse it plainly, you can't reuse the same key cipher, but if I have K1 هنا, so you know, if I go back, let's go back to the picture. So if I go back to the picture, and instead of giving just the key, what I said, we'll give something called an initialization vector. We'll give a randomly number generated called IV. So the feed هنا will be two numbers, the key and the IV. So, and then the first set of bits أرسلها هنا is the IV. Let's say the IV is 128 bits. So when the receiver comes, right, an attacker can see the IV, but who cares? Because they see the IV. To get to the key stream again, they need the key and the IV, but the key is secret. It's only known by the sender and the receiver. And only knowing the IV, it doesn't help. But when the receiver who knows the key receives the IV, ياخذ الIV, concatenate it after the key, feed it back here to the algorithm, and then get this key stream, and then do the decryption. So message number one, I do IV1. If I want to send message number two, I create another IV, and I send it in the plain text. 1, 2, 3, 4. Every time I create a new IV, instead of feeding to the algorithm the key itself, I feed it the key and the IV. I get different key stream every time I do the encryption. So does the stream cipher exist in real life? Yes, 100%. So we have something called RC4. It was used very widely in WEP, SSL, Microsoft Office. طبعا now it is considered to be insecure. Bluetooth uses عفوا E2. GSM encryption سابقا ب 3G, and some of the 4G uses an algorithm called A5. A5 is a stream cipher, حتى encryption في الجوال والصوت or whatever. So it was widely used because it's easy to compute and fast. طيب, I'll basically stop here, and next lecture we will be talking about the block cipher in modern crypto.